Standard deviation is just the square root of the variance. So for population standard deviation, look at the symbols we use. Population variance, it's a parameter, so we use the Greek letter sigma square. And for population standard deviation, we use sigma, just the square root of sigma square. So in this example, you find your variance. First, 8.9 take square root, it's about 3.0. Standard deviation has the same unit as your data entry. So for our example, the data entry 41 represents thousands. So 41 is $41,000. And then the deviation, the standard deviation 3.0, it's also has the same unit, so that means $3,000. So these two parameters are used to describe the variation of your data set, like the spread. The larger, the more variation your data set has. But as you can see, it's not easy to calculate variance and standard deviation manually. It takes time. So we can use StatCrunch. As we showed in section 2.3, you can just enter your numbers and then click Stat, Summary Stats, and click Columns. And in this box, just choose unadjusted variance for population variance and unadjusted standard deviation for population standard deviation. So if we do this, use the first example. So if you choose variable 1, and you can see here we have variance and the standard deviation, but this variance and standard deviation are sample variance and sample standard deviation. So they are S square and S. Here we want sigma square and the sigma. Do not use that. Choose the unadjusted. So unadjusted variance and unadjusted standard deviation. Then you can get data. Okay. Here I use different examples, so no, that's why they're not the same. But if you follow the steps, you'll get exactly the same number as you got manually. Now it's back to sample variance, sample standard deviation. For sample variance, we square the deviation, square each deviation and add them together and then divide by sample size minus 1. So that's the difference between the formula of population variance and the sample variance. Here you divide by the population size, capital N, but here you divide by the sample size minus 1. Well, sample standard deviation is still the square root of sample variance. This will be S squared VS. And that's why in StatCrunch, make sure you pick the right one. So unadjusted is the population. Without unadjusted, if it's just variance or standard deviation, that will be sample. So you can see here the example. Find the deviation, square each one. Now if we treat this as a sample, so if the corporation has other branches and they only select Chicago branch, that will be the sample. So that's not the population. This will be statistic. And let's find sample mean. It's 41.5, and then you find deviations. Again, if you add all deviations together, you'll get a 0. You always get a 0 for doing that because the positive deviation will cancel with the negative deviation. But if you square each deviation and add them together, it's 88.5. And then let's divide by sample size minus 1. So it's not 10, it will be 9. And then that's 9.8, the sample variance, and the sample standard deviation will be 3.1. If you compare with the last example, you'll find they're different. This is 8.9, 3.0, and this is 9.8 and 3.1. Although they're not very different, because divide by 10 or divide by 9, it's not a big difference. But in the exam, if you did the wrong formula, your answer will be wrong, no matter how close they are. There's still wrong answer. So make sure you read the conditions carefully or read the problem carefully.